Hello, welcome in today's lectures from TYBSc Physics third paper Atomic and Molecular Physics. The today's topic of discussion is atoms in magnetic field or Zeeman effect. Student, as we know that whenever the atoms placed in magnetic field, it acquires additional energy due to magnetic field. Means the electrons in particular orbits having angular momentums and its which can be specified by its orbital quantum number. Then in we have also seen the hydrogen atoms in magnetic field. It acquires additional energy due to magnetic field and produce energy levels. And what happens when the energy levels are formed in the atoms? So the electrons in upper energy levels can transist or can jump from upper energy to lower energy. In that case, the radiation or it emits the radiation in the form of electromagnetic waves. So now we study how the atoms, there are different types of atoms, how they will react in magnetic field. So the first, the spectra, how the spectra can be behave in magnetic field. Now the first, this effect magnetic field applied to the spectrum or a simple sodium flame by the Faraday, but there will be no change in the spectrum which can be observed because of the resolution of the spectrometer. But after that, the Zeeman was the scientist and who first observed when the spectral lines passing through the magnetic field, and he observed that and he detect with high resolution spectrometer and observed that the spectral lines split up into its components, and he observed three components and more than three components. So in this topic we are going to learn the Zeeman experiment and his observation. The very simple one, the source of spectral lines which gives a spectral lines a fine beam or intense beam which can be passes through the strong magnetic field up to 30,000 Gauss or 3 Tesla, and this magnetic field is produced by using electromagnets by the current passing through the coil, and the spectral lines are observed in two views, which is perpendicular to the magnetic field and parallel to the magnetic field. So for the parallel to the magnetic field, a small hole drill along the axis of pole piece of this magnets, and this detected lines which can be passes through the spectrometer, so we can observe. So the first observation, now the sharp intense beam lines, spectral lines, which is position at frequency V naught, that is some particular frequency in a calibrated spectrometer. And what happens then, magnetic field is applied, turn on, and observe perpendicular to the field. Then it is observed that there is a three lines is observed, clearly observed, and which is a equidistance from the our original frequency nu naught. So on the either side of, there are three lines, so at the center lines which is having frequency nu naught, and on the left side which is the frequency of nu 1, and on the right side the frequency of nu 2. So if you take the difference between these two, on the left, that is nu naught minus nu 1, and other is nu 2 minus nu naught, then this difference is exactly equal to the what that is charge. What is the magnetic field is applied? Charge into magnetic field EB upon 4 pi m, where E is the charge on electron and m is the mass of electrons. So in today's topic, what is the Zeeman effect? How the Zeeman can uh, observe this effect? So if we state Zeeman effect nothing but the splitting of spectral line into its several components by applying external magnetic field known as Zeeman effect. So if there are the three lines is observed, then it is known as normal triplet. If more than three lines observed, that is the another type of Zeeman effect, that is anomalous Zeeman effect. So normal triplet and non-normal triplet, there are two types of Zeeman effect can be possible. Now the Zeeman placed this strong magnetic field and perpendicular. If we observe this diagram, so you will understand. So the source of spectral lines which gives sharp lines and which can be passes in magnetic field. So magnetic field is perpendicular, which can be applied by the strong electromagnet N pole and S pole. So there is two spectrometer positions. So one position at downward side which is perpendicular to the magnetic field, you can see, and another that is in the direction of parallel to magnetic field view. So in first perpendicular view, if we see this spectral lines, that is one frequency of spectral lines which can be split up into 3. So having the frequency will become nu naught, nu 1 and nu 2, and this spectral lines which is linearly polarized. Before entering the magnetic field it is unpolarized, after splitting it will become polarized. And if you take the difference, that difference is, that is nothing but the shift in this spectral lines, or Zeeman shift it is also called as delta nu, which is equals to nu naught minus nu 1, means right hand side is more frequency than left hand side. So nu naught minus nu 1, or that is also equal to right hand side nu 2 minus left hand side nu naught, and which is equals to EB upon 4 pi m. So that shift we can calculate by using this formula, charge on electron, magnetic field applied, and divided by 4 pi m. So this is the first observations, and the second one is when parallel views to magnetic field. So in this case there are two lines are clearly observed, and which is at that frequencies nu 1 and nu 2 that observed, and in this case the nu naught frequency is not observed. And if we take this difference nu 1 and nu 2, that is 2 times delta nu. So this nu naught frequency is absent, and this splitting spectral lines is circularly polarized. So in this case, in perpendicular views it is a linearly polarized splitting lines, and in parallel views the spectral line split up is circularly polarized. And in this case nu naught, the original frequency is not observed there, but if we take the difference between nu and nu 2, that is 2 times delta nu. So this is first observation. Next one is when the light is entering and split up into 3 components, nu naught, nu 1, nu 2 were linearly polarized, and when spectral line observed parallel to the magnetic field, only 2 components of frequency equal to nu 1 and nu 2 were observed, and nu naught was not observed. the separation between observed component nu1 nu2 which is equal to that shift will equal to 2 delta nu. Now the splitting of spectral lines into three equidistant components. Now the difference between any two successive frequency lines that will gives a equidistance. The separation or the difference is the same. Nu naught and nu 1 on the left side, nu 2 and nu naught on the right side. So this difference is always equal. So such type of this triple three lines, or that is called as three equidistant component in presence of external magnetic field, the separation of successive lines or shift is equal to Eb upon 4 pi m, is called Norman-Zeeman effect. If the three lines is detected, but the distance between these two lines, successive lines, are not equal, that is not Eb upon 4 pi m, then such a triplet is called as non-normal triplet. If the difference is delta nu equal to Eb upon 4 m, that is called as normal Zeeman effect, or that is called as normal triplet. And if the spacing is not equal to Eb upon 4 pi m, then it is called as non-normal triplet. Now there are two types of generally Zeeman effect is there. One is normal Zeeman effect, in which the splitting of spectral lines into threes and they are equidistant. And in anomalous Zeeman effect, if the splitting of spectral lines more than threes and the spacing between two lines, successive lines, are not equal to Eb upon 4 pi m, so this is the complex spectra, splitting of spectra, anomalous Zeeman effect. So anomalous Zeeman effect is a spectral line split up into three or more than three and not equal space or equidistance, or that is non-normal triplet in presence of weak magnetic field. When the field is strong, then it gives normal Zeeman effect. If for weak magnetic field, it gives splitting more than 3 and they are not equidistant. So the normal Zeeman effect is observed in atoms which is having total spin. That is very important. If the spin angular momentum, total spin angular momentum is 0, then total angular momentum of that atom particularly equal to, as we know that J equal to L plus S, but S equal to 0, so J equal to remain L. So all its phenomena can be explained by using orbital motion or orbital angular momentum of that electron. And what are the source of normal Zeeman effect? Which source can be used to produce normal Zeeman effect? Which can be generally used calcium, copper, helium, magnesium, etc. And for anomalous Zeeman effect, the source which can be used mainly the alkali elements like sodium, potassium, chromium, etc., or the atoms having non-zero spin which can exhibit anomalous Zeeman effect. So today's this is we have seen all about the Zeeman effect. So you understand, you can write the notes and study well to understand. So in next lecture we will learn about more about the next topic. Till then, stay tuned and thank you.